Welcome to this video on multiplying fractions. Let's begin. So first of all, we're going to take a very simple example, 1/2 times 1/3. And visually, what does that mean? Let's look at this picture. So if I look at 1/2 times 1/3, well, notice that I've already taken this picture here and I have a shape that represents 1/3. Okay, so this is representing 1/3. Okay, so I want to take half of that shaded region. Well, what would that look like? Well, that means that I take this shaded region, I literally divide it in half, and then I just take half of that. Now, notice that I've just cut that one region in half, so it's a little bit confusing. What we really need to do, and what we are doing, is we're just dividing every single section in half. So now let's count how many sections we have when we cut all of those pieces in half. Well, that means we have 1, 2, 3, 4, 5, 6 pieces. Okay? So if I take half of 1/3, that means I still have 1, right? But I now have 6 slices instead of 3. Mathematically, this is probably the simplest operation to do with fractions because all I have to do is multiply across on the top and multiply across on the bottom. So 1 times 1 is 1, 2 times 3 is 6. Okay, so half of 1/3 is this shaded region right here. Again, that represents 1/6 of the total pie. Let's do another example. Okay, in this problem I have half of 3/4. So down here, I'm going to color in 3 of the 4 sections, okay? And again, this picture is representing 3/4. So I want to take half of that. So again, I'm going to take all of my slices and I'm going to cut them in half, okay? So now let's count the number of slices I have. I have 1, 2, 3, 4, 5, 6 shaded slices, right? Okay, and I have a total of 8 slices. Oops, sorry. I have a total of 8 slices. Okay, so if I take only half of those slices, right, I would take 1, 2, 3. Notice that 3 is half of that. And then so basically I end up with 3/8. Okay. So, again, the easiest way to understand this is just 1 times 3 is 3, 2 times 4 is 8. Okay? So if the visualization, right, of multiplying 3/4 times 1/2, if that is confusing you, if that is not helping you, okay, then please just remember, with multiplication, you just multiply across. 1 times 3 is 3, 2 times 4 is 8. Okay? The thing to understand here, and the reason that I think the visualizations are helpful, okay, is that you end up with smaller fraction, right? The shaded region is 3 slices out of 8. That's smaller than 3/4. So if you have two fractions that are smaller than 1, then the product has to be smaller still. If I take half of 3/4, I have less than 3/4. Specifically, I only have half of it. All right, let's do some more examples here. So now I have 2/4 times 1/3. So 2/4 is this right here. Okay, and if I want 1/3 of that, well, what would that mean? Well, that means that I would have to take each of these 3 sections here, and each of these 4 sections, and I would have to divide it again in thirds. Okay, so now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so how many shaded slices do I have? I have 1, 2, 3, 4, 5, 6. Okay, so what is 1/3 of 6? Well, that's only 2. Okay, so let's do our math. It's really easy. 2 times 1 is 2. 4 times 2 is 12. Okay, does that match up with our picture? Absolutely. We have 2 slices out of a possible of 12. However, something interesting happened here. right? 2 over 12 is not reduced. We always have to reduce fractions. Okay, in this case, we can divide top and bottom by 2, and we get 1/6. Now, let's look at this math again. 2 over 4 times 1 over 3. Is there anything I could have done to either of these fractions to reduce them before I multiplied? And the answer is yes. Okay, 2/4 reduces to 1/2. So I could rewrite this as 1/2 times 1/3, right? Multiply across, you get 1 over 6. So if I reduce my fractions first before I multiply, in other words, if I divide before I multiply, okay, then I can actually save myself a lot of time in the end by not having to reduce my fractions. So let's see if I can make sense of that. So I have 5 over 7 times 14 over 10. So there's no way to reduce 5 over 7. And what about 14 over 10? Can I reduce that? Absolutely, right? 14 over 10, if I divide by 2, and I divide by 2 here, that gives me 7 over 5. That's interesting. So I could rewrite this as 5 over 7 times 7 over 5. I wonder if there's anything else I could do before I multiply. Well, you may or may not remember that multiplication is commutative. That means it doesn't matter what order you're doing it in. So first of all, I could rewrite it as 5 times 7 on the top and 7 times 5 on the bottom. And then, look what happens here. If I move things around, 7 times 5 over 7 times 5, these reduce, right? 7 divided by 7 is 1. 5 divided by 5 is 1. So I get 1 over 1, or just 1. Okay? I could also have done that back in this step, right? 5 divided by 5 is 1 over 1. 7 divided by 7 is 1 over 1. Okay? So I literally just get 1. What would have happened if I didn't do that? Let's see if we just multiply. Well, 5 times 7 is 35. 7 times 5 is 35. So I still end up with 1. Okay? So if you're comfortable with your times tables and you know how to reduce fractions, that can save you a lot of trouble. Let's see if we can do another example. So how about we do the problem, sorry about that. What if we do the problem 8 over 15 times 3 over 4? Okay, so 8/15 cannot be reduced. 3 over 4 cannot be reduced. However, let's look at 8 and 4. 8 over 4 reduces to 2 over 1. How about 3 and 15? Well, 3 goes into 15 5 times. So this becomes 2 times 1 over 5 times 1, which is just 2/5. So hopefully you can start to see that by reducing first, you can save yourself a lot of time. What would have happened if we just multiplied straight across? Well, 8 times 3 is 24. 15 times 4 is 60. If we had multiplied first, it might have taken us a long time to get from 24 over 60 back to 2/5. So again, if you take some time and reduce first, you can save yourself some work. Let's do a few more examples. Let's say I have 17 over 12 times, let's say 6 over 34. Okay, so is there anything that I can reduce? Well, one thing that we can reduce is 6 over 34. 6 over 34 reduces to 3 over 17. So then what can we do? Well, 17 divided by 17 is 1 over 1, and 3 goes into 12 4 times. So this reduces to 1 over 4. Okay? Again, you could absolutely multiply across, but that's going to take you a much longer time to get back to the fraction in simplest form. So think about simplifying and reducing before you just multiply. Okay. What if we have 8 over, let's say, 33 times 11 over 12? Okay, so 8 over 33 cannot be reduced. 11 over 12 cannot be reduced. But what about 11 and 33? Well, 11 times 1 is 11. 11 times 3 is 33. What goes into both 8 and 12? Well, 4 does. 8 is 4 times 2. 12 is 4 times 3. So 2 times 1 is 1. 3 times 3 is 9. So again, just by taking some extra time and simplifying, we can save ourselves a lot of work. Again, if we had just multiplied across, we would have had 88 over 33 times 12. 33 times 12 is a huge number. 396. Right, so to get from here all the way back to 2/9 might have taken a bit of time. So let's do maybe one more example. Let's have 3 over 17 times 34 over, let's say, 15. Okay, so 3 over 17 cannot be reduced. 34 over 15 cannot be reduced. However, 17 times 2 is 34, and 15 is divisible by 3 5 times. So this reduces to 2 over 5. Again, you can absolutely start by just multiplying across. You would get 102 over 255. Okay, but again, for me to get from 102 over 255 back to 2/5, that would take a really long time. So I would prefer to reduce it and simplify it first, and then save myself a lot of bother.